All right, here's another one of our rules here. We have chain rule. Chain rule is probably used. I'll probably say the most out of all of our like rules with like product and everything like that, because technically you could do chain and then you end up like doing product at the same time or quotient at the same time. So it can really all be done together. So
this is just like quotient rule and product rule?
it's kind of, it goes along with that family. You have, product rule, is first times for second times for first, quotient, look, how much, how you go. Look, chain rule is one of its own. So basically you have a function within a function. So basically your problems are going to look like composites. It looks like you put a function inside of another function. And so to find the derivative of that, you're going to take the derivative of the outside, and then you'll have the inside, and then you multiply by the derivative of the inside. So basically take the derivative of the outside first, and the derivative of the inside. So here's our function that we're working with. To take the derivative of the outside part first, we have the inside. Okay? Well, you have, so the derivative of the outside would be, you have the 6, right? Right? So you bring it to the front. So you have 6 times 4. This stays the same. What do you use the exponent? Minus 1. So there's the derivative of the outside.
Times the derivative
Times the derivative of the inside. So what's the derivative of 5x cubed plus 2?
15x squared.
15x squared. Because you multiply the 3 by the 5 that's on the inside and subtract 1. So you basically have 24. And then 5x cubed plus 2 to the 5th. And then you can actually multiply your numbers on the outside, which are your 24 and your 15x squared, to get a bigger number. And that will be your derivative. Alright, I was like, how did I do this? I can't remember. I really can't remember. So basically, like I said, because it's a composite. So your first function, or your outside function, would be 4x to the 6. And then your inside function would be 5x cubed plus 2. Okay? Yeah.
I don't know, I thought it made more sense the first way.
If you look at that, it's like these everything comes out.
Yeah.
That one's like
That's true.
introduction.
That's why I learned it last year.
Yeah,
I
this was great introduction. So AJ, if I did composites, right, I would basically put this function in for x, right? And I will give you the original problem. So if you take the derivative of the outside, which is this, you can take the derivative of this integral. Okay? And then you take the derivative of this part. So basically that 24x to the 5th, and then the derivative of 5x cubed plus 2 is right there.
I've just substituted.
It is. So it takes an ongoing order.
And you cannot go any further than this.
Now let's take the second derivative order.
So today it's just all chain rule practice. Okay? It's just all chain rule practice. Because we have a short period. So here we go. Here's one. It's another chain rule. Alright, so here we go. So remember, this can be written as all this to the 1/2. Okay? So think about it. You have your outside function, and then you have your inside function. So it's the derivative of your outside. What's your outside function?
1/2. X.
To the,
Negative 1/2.
okay? But x is actually, okay? Then you multiply that by the derivative of your inside, which would be 8x. Okay? What's half of 8x?
4x.
4x. So we have this. Okay? Which is also the same as 4x over 4x squared plus 1 to the positive 1/2. Or you can write as a radical and then rationalize your denominator and keep on going. But if you get to this part, then I'm pretty sure from there you should be good to go. Okay? Alright, here's the next one. Okay, So what are your two functions that you see here?
X squared. Yeah.
Okay, so this is your outside function here.
Wait, you're at the X.
X squared is your inside.
Oh, that's already wrong.
Okay, so what's the derivative of the outside?
The outside,
Yeah.
E to the x. But we're not going to write x. We're going to write
the derivative of the inside.
x squared. Then you multiply it by the derivative of your inside, which is 2x.
Oh.
So this answer is 2x e to the x squared.
X squared be outside though?
Uh,
Wait,
Thought it was.
Thought it
and
was.
then you just plug in E to the X to X.
It will work that time, but
How is that? How is X squared inside?
Like
thought it
E to
was
the X is.
It was inside the E.
mm,
Because the E is usually right.
because think about it. If this was the function that e to the x was getting plugged into, this is what you would have, which is e to the 2x, not x squared.
Okay.
So that's why e to the x is the outside function. When you plug in x squared, you
Same
get
thing.
to the x squared.
Oh, so we should have it.
Alright, I need to write that down.
Okay. Let's look at the next one.
So,
No, we didn't. Last time.
What are you talking
I don't know. I feel like just.
so the proof.
Here's the next one. So, you have your outside function, you have your inside. What's the derivative of the outside? And you multiply, and what technically is x? The 9x plus 2. So then you multiply by the derivative of the inside. What's the derivative of 9x plus 2? 9. So then you multiply. What's 2/3 of 9? 6. So good job here. If you went the next step, it would have been to make that positive. So good there. Could have kept going.
Do we have to keep going?
No, like honestly, like once you probably gotten to like this point, I would have been like, okay, that's fine. Because we don't deal with negative exponents.
See?
There you go. And then you go. You know.
Can you explain how chain rule gets you the slope of
I mean, rationalizing.
Remember, well, chain rule, just like any of the other rules, they basically are the equations in which give you, which whenever you evaluate a particular number, gives you the slope
Yeah,
of that particular tangent line.
So like,
simple
if
as
it's to an odd
And so
power, you don't
that
have to write
formula, that process can give you that equation that you'll plug in to get your slope.
It's a rule.
So you find the derivative.
Why is
like,
it the
how
rule
you
like that?
don't question it.
I'm not
How
questioning.
you apply it to
You
life.
just said why.
So, real life
Now they
application,
came up.
like, yeah, this, like, position, velocity, acceleration. All those deal with the derivatives.
Speed is.
No,
Yes.
it's displacement,
Oh, I forgot.
velocity,
Acceleration,
acceleration.
which are all derivatives of the original position. Here's the next one.
Pretty mean.
Then that's the next little bit of derivatives that we'll get to.
Not today.
No, that's not shooting. When is this one? I got it all laid out. Like we're doing this for the next 2 weeks. All derivatives.
Just like good.
It's a lot easier than it was last year,
Yes.
and we already learned it last year. I forgot about
We
it.
should do it 3 weeks, not 2 weeks.
We did not do
No,
2
I'm
weeks.
kidding.
It was like a month and a month and a half.
It felt like 2 weeks. It was so fast.
Is this right?
Just because I didn't know what we were doing.
Right.
No.
Oh my gosh, Caitlin.
there's just these powers canceled.
I mean,
So if I have like the cube root of something to the fourth power, is it just that to the first power?
it'd be up to the fourth power. Now if you have cube root of something to the third power, then those cancel out.
Yeah.
But now when it's like a four or a nine, it's a
Now when they're
multiple
not
of
the same.
three. They're not a multiple.
Okay. So like if I had the cube root of 3 times something to the 9th power, it would be like something to the 4th power?
Something to the third power, which you divide.
Okay.
We have a test.
Hold up, let me see.
Oh.
Wait, hold on, you got,
You got math.
got it, okay.
Got math.
Oh, we didn't do this.
Good. Sorry, I'll just. It looks good, yes, good job, yes, I see different variations, okay, wait, before you erase, I see. Oh, you have both yours, that's one, okay, so you have this one, okay, where you can make your exponent positive by bringing it to the bottom, okay? Or you can have it as, it's yours, with the
Kind of
root,
small.
rewritten as the root, okay, the cube root of all that to the fourth, you can have it here, okay? So all very good.
Let me see.
What if you wrote an entirely?
Yay, guys, we did it.
I thought you couldn't.
You're not,
It's improper.
you're not supposed to, but they're not, they don't say anything.
It's like, so basically Annabelle's, then to
Mine.
Brenda's, then to Jacob's, like, that would be like going in like the most simplified form.
Or
And then you could go further.
Well, it gives us all of them on
Well-
this, on this station.
Well, a lot of times, like, you wanna go to like your most simplest form, and then like problems like this, you just wanna go to where your exponent is positive. But realize this is just like usually the first step of some of these problems, you know, after that, they'll actually figure out the slope of the particular curve, and so you have to do the derivative and plug it in. So a lot of times, you know,
Yeah, this is like part,
so a lot of times, you know, you get into a particular, you find the derivative, and instead of really like worrying about all the simplifying process, you just plug in your number, and then you simplify that after you plug in. Okay.
this is like part,
It's a tad different. Well, go back to simplifying this one problem.
it's too much when you get 5-page test for 2 questions.
whoa, pretty, pretty scary. Whoa, hold on. Hold on. Maybe like how I use that little dot on the board. I wrote that in, and I was like, dang it, I can't.
Like I said, all these like
Oh,
first
it's
steps
already,
and all these problems. So we got to make sure we can figure out the derivative. If we can't do that, we can't answer no other part of this problem.
And that's unfortunate, because it's probably like a 14 question.
Yeah. So crazy, like when I look at the IB exam every year, I'm just like, oh God, I can do like great topics into one question. Like that's like double quadratics, you actually convert it to a vertex form. And then it'll ask you to find the slope at a particular point, and then it'll put an application problem like, you know, Toby's, you know, building a box that models an equation, how do you
Find the maximum area of the box.
exactly, and I'm just like, oh my
This time, yes.
So there's some good questions, but Jesus. And I could have sworn I paused this thing, so all that is on video right now. So, alright, you have your outside. Your outside is e to the x because you're inside. The function that went into e to the x is 4x. So what's the derivative of e to the x? But I'm not going to write x, I'm going to write, and then I'm going to multiply by the derivative of my, so it is 4 e to the 4.
I did it.
No, my favorite ones are the ones that take these types of problems and make you find like the fourth the derivative of it, and you just and then recognize that there's a pattern that's actually geometric, and then once you write the
Oh yeah, can we do that? When do we do it?
That's all you do integration. So
These
the
IQ
same one
questions
that
make me like,
We'll do it right. It's just too practical.
Here's the next one.
A triangle with two obtuse
When
angles.
is the last?
Figure it out.
Take our
Like, isn't that
the
the?
expos and
Like, solve this paradox. Go.
Are you close?
Do it.
Isn't it possible for triangle?
Do it.
The section, how do we do
This
on
does
our
not
free
equal
test
this.
meeting?
Why does
It's
it-
not gonna be okay.
Are you're closing with that?
Yeah, but you can still retain it if you're taking with a different teacher. Not me.
You can retake it.
Cause the way that we have it set up now is that, basically,
This-
here's the next one.
Boy.
Nah,
48X.
What y'all get? Oh.
You don't need
48X.
yeah, you don't, yeah.
I guess it's weird.
Cause you subtract one from the X one.
No, you just-
The inside is 4x plus 3. So then you multiply 12 by 4x
Oh,
plus 3,
you
you get
cannot subtract
48.
one from your.
No, I don't know why I just was screwed. I thought I saw, X from,
Like-
I mean, after so.
Do you have to
But it was
put,
two X.
I don't know if you put parentheses around this, or if you just write it like
This is
Yeah, that's how.
Alright. Alright, well, let's see. Let's do a few more,
Joaquin, this is all your fault.
I'm not.
Yes, it is. Whatever's about to happen, it's your fault.
I mean,
Oh, see, here we go. Alright, they're gonna get a little more challenging now. Okay, a little more challenging now.
Discover the difference between killing and
So, this can be rewritten as x squared plus 1 raised to the negative 1, okay? No, this is not, with your 1 over x, okay? So be cautious of that. So, plus the derivative of 1 over x is an ln of x.
Yeah, I
It
did
is.
it.
So you gotta be careful.
Yeah.
Let's write as antiderivative. So here we go. Bring down the negative, and this becomes a negative 2. You multiply by 2x. So then you have negative 2x times x squared plus 1 to negative 2. So then the negative x over x squared plus 1. Okay? So again, just a tad bit harder. Clear your boards. Here's the next one.
It's way more fun, right, Joaquin?
I mean,
So I need product here. The first times the derivative of the second. The second is where chain rule comes in. So you take the derivative of the outside. You multiply by the derivative of the inside. So that is for product with the first times the derivative of the second. There's your chain rule there. Then plus the second times the derivative of the first, which is just 1. Then it's just a matter of simplifying. 1/2 and negative 2x make it negative x. Negative x times an x makes a negative x squared. Yep. So that's what you'll have for that first set. Then plus one minus x squared to the 1/2. Is everyone okay up to here? Okay. So when you take the derivative of that 1 minus x squared, that's your inside function, and this is your outside. Okay, this is your chain rule. So you take the derivative of the outside, which is 1/2.
Oh, that was right.
It is. So this is the product rule. It's first times the derivative of the second. So this whole thing is the derivative of 1 minus x squared to the 1. Times the derivative of the outside. So all of this is the derivative of the second piece. Then plus the second times the derivative of the first, which is x, which is 1. And so this third line is nothing but simplifying that second line down. So then, if you want to simplify some more, this will become negative x squared all over 1 minus x squared to the positive 1/2. Oh, technically it's on the top.
No, but if you wrong, you can
Wait.
switch the x negative x
technically, because you have to, all the way to add them is the common denominator.
I worked the negative square.
Negative 2x times 1/2 is a negative x, times x is a negative x. Other questions? Got time, I think maybe for one more, maybe? Yeah. Oh, yes. Let's do one together, put one in your notes, let's do one together, okay?
Jesus.
Okay,
This
because
is-
this is
This
chain
is
rule,
double chain rule.
this is a double chain rule.
No
Okay.
chain rule is not that hard.
So, you have your outside function, which is of course e to the. I know how you do this. Then you have the inside,
Which is 2x to the fourth.
You have the outside.
And then the inside.
Oh, okay,
Which
see
is
where,
you
3x
can,
minus
you can look at it like this.
and then the inside,
And see, that's the issue, your inside has another
inside.
inside, okay? And that's when you run into the issue. So basically, what's the derivative of e to the x? E to the x. So I'm not gonna write x, I'm gonna write 2. I'm gonna write all the good stuff. Then I have to multiply it by the derivative of the inside. Well, the inside itself is another chain rule. So the chain rule for this would be
8.
8 raised to the third. But then you have to multiply again by the derivative of the inside, which is so it's 24 e 3x. I have my 8 in one spot. There you go. Now again, will something like this multiple complex be a derivative problem? Not where it just asks you just to find the derivative itself.
That would definitely get copied.
This will be one where they want you to find the slope and they want you to take the derivative of this. So once you get to this line, plug in that value. Okay, don't worry about the simplifying part, but once you find what the derivative is before you simplify, then plug your number.
Oh, that'd be so terrible.
Okay.
Because then you know it's gonna have like a